Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session we have started the mechanical properties of fluids or the fluid mechanics. So where the first lecture we dealt about the basics of the fluid mechanics, right? So how the pressure varies if we go inside a liquid, right? And also we dealt with the pressure at horizontal points, at equal horizontal points will be same, right? So these are the concepts we dealt in the last session. So today we are going to discuss the pressure in accelerating fluid, and so barometer and manometer concept, and then the Pascal's law. Okay, so these are our three objectives for today's session. So as usual, I just need your attention for the next 1 hour. Just be with me, avoid all the disturbances around you guys, and at the end of the lecture it's very important to prepare your own short notes. And just I'll spend 2 minutes because the JEE NEET dates were announced. So the students, sorry, you guys are in 11th, right? My bad. So for the 12th, so those students who are in class 12th and following these lectures, so it's very important to plan your class 11th and class 12th simultaneously, guys. Very important. So complete the class 11th and class 12th. So finish off your syllabus as soon as possible and do more of revision, and do attempt the first session sincerely. Okay, so the first attempt is going to be the last attempt, so like that you should prepare. Clear? Chalo. So let's start with the today's concept, how the variation of pressure in vertically accelerating fluid. So the fluid is accelerating vertically, so how the pressure varies. So in the last class we studied, so consider, let's suppose this is a container in which the liquid is filled. Now so let's suppose if we place, so here the pressure, let it be P1, here the pressure, let it be P2. So we already know that pressure P2 will be equals to P1, so let this height be h, so plus rho g h. So this liquid has some density rho, so P2 is equals to P1 plus rho g h. So or you can also write P2 minus P1 is equals to rho g h. So where I can write this is also called the gauge pressure. Yes, so this is what we have studied it in the last session. And so for the static fluid, this concept is for the static fluid. The static fluid, right? The fluid is at rest. So now, so why the extra pressure is coming, sir? So this rho gh is due to the weight of the liquid column, right? So the rho gh, it's a extra pressure, it's a extra pressure which is due to weight of liquid column. Yes, it is due to the weight of liquid column. In the last class we discussed about it. Fine, so this is fine. And one more concept also we discussed. So for a static fluid, or if the fluid is in equilibrium, so for the static fluid, so the pressure at the same horizontal level will be equal, right? So for example, so this is a container, so then here the liquid is filled like this. Now so see here, if I consider the pressure at this point is P1 and the pressure at this point is P2, so for the static fluid, so that P1 will be equals to P2, so the P1 will be equals to P2. So because at the same horizontal level the pressure will be same for the static fluid. So at the same horizontal level, pressure will be equal. So based on this, we have solved the YouTube problems in the last session, right? So now let's go for what happens, how the pressure varies in vertically accelerating fluid, and what will be the shape of the liquid, so the which is there in the container. So that we'll see now. See here first. So if liquid is accelerating vertically, so try to understand the concepts, so then we'll focus on the questions. So if the liquid is accelerating vertically, for example, this is a container. So in this container we have the liquid, okay. So now if this liquid is accelerating upward, so then, so what will be the pressure at this point? So at which point we can consider? So let's consider, so what will be the pressure here at the bottom? So how do you write the pressure in this case? So whether the pressure increases or decreases. So the first thing is, so this liquid will change the shape first of all. If it is accelerating, so this liquid will change the shape. So how it will change the shape, we'll see it in the next slide. So but the pressure varies, the P2 pressure, which will be equals to, so here there will be some force which acts downward. Previously in the static fluid, the pressure increases due to the weight of the column. So here along with the weight of the column, as this whole container is accelerating upward, so there will be some pseudo force, the MA this will be the pseudo force. This MA is going to be the pseudo force which acts on the liquid column again, yes, and then its own weight will act mg, right? So now, so the pressure is equals to, so let's say the top pressure is P1, so and the pressure at the bottom is P2. So P2 is equals to P1 plus, so in this formula this G is called the G effective you should take. So this G is there na, so this G effective you should take. So the G effective in this particular case, will be equals to, so G plus A, yes or no? So this is a G effective. So now in place of rho, G effective into, so let the height be h, so then this will be the P2 will be equals to P1 plus rho, in place of G effective I am writing G plus A into h. So this is how the pressure varies. So if the liquid is accelerating the vertically upwards, so in this particular case it is accelerating vertically upwards. Clear? Understood, guys? Chal. So what's the extra pressure if they ask? So the gauge pressure in this case will become, this is the extra pressure, P2 minus P1 is equals to rho into G plus A into h. This is the extra pressure. Done. So the same concept you can write. So here let this height be h, here the pressure P1, here the pressure P2. Obviously the pressure increases. So what if the liquid column is accelerating downwards, sir? So the pseudo force will act upward, that's it. So here let's suppose this is a container, in this accelerating vertically downwards, okay. So in that case the pressure, so what happens to the pressure? So here also the P2 will be equals to P1 plus rho G effective into h. So what is G effective in this particular case? So here the liquid column weight mg will act downward, and then so the pseudo force ma will act upward. This is a pseudo force which acts upward. So now I can write here the G effective is going to be in this particular case, so the G minus A, the G effective is G minus A. So which is equals to P1 plus rho into G minus A into H. So this is the pressure at the bottom. Clear? How the pressure varies in case of vertically accelerating fluids. Done? Chalo. So next. Done? Chalo. Next. So now the variation of pressure in horizontally accelerating fluids. So previously the two cases that I considered, the fluid is accelerating vertically. So this way and this way. So now what if fluid is accelerating horizontally? So let me take the container in which, so if it is the static fluid, first of all, let's write, if it is a static fluid, consider this is a static fluid. It's not accelerating. So then the pressure at same horizontal level will be equal. So let the pressure P1 here, let the pressure P2 here. So here the P1 will be equals to P2. Yes, this point we already know. Now let's take, so this container is accelerating towards right. So the container is accelerating towards right. It is accelerating towards right. Okay, so now understand the concept. See here. So this is a liquid which is filled in it. So just try to understand the concept slowly. So here this is a liquid column I am taking. So let the pressure here it be P2, let the pressure here it be P1. So now first of all, where the fluid, where the pressure will be more? Which side the pressure will be more? So tell me, which side the pressure will be more? So try to understand from here. So when it is accelerating right side, so the pseudo force which acts left side, the pseudo force which acts towards left. So due to this pseudo force, what will be the pressure? Due to this pseudo force, what will be the pressure? The same concept. So see here. So here let me write the pressure is P2. So I am writing, so the P2 will have the more pressure at P2. So there will be more pressure, and at P1 there will be less pressure. So let me tell you simply. So this is L. So now what you do is, you just keep this horizontally. You just keep this one horizontally. Okay. So then I'll get, so P2 minus P1 is equals to rho GH. Actually in this case the P2 minus P1 is equals to, I can write rho GH. Where in this case, where is that? So this one, so I can, where is that? Sorry. So this one, P2 minus P1 is equals to rho GH, right? So if this height is H. So now in this particular case, so same one, it is flipped horizontally. So here I can write P2 minus P1 is equals to, P2 minus P1 is equals to, let the density of the liquid be rho into, so A L. So this is a formula, guys. So rho A L. So where A is the acceleration, and see previously it is rho GH, right? When it is placed like this, where is that? So it is placed like this, the pressure at second point will be more. P2 pressure is more. P2 minus P1 is equals to rho GH. Yes. So the same thing, if I flip horizontally, so and it is accelerating, so that the, due to which the pressure is increasing, due to the acceleration, right? So that's why P2 minus P1 is equals to rho acceleration into the length. Done. So previously here, due to which the pressure is increasing here, acceleration due to gravity, G, due to its own weight column, weight of the liquid column, right? So that's why rho GH. Here it is rho AL. So have you guys understood this part? So just note this point down. Very important, this formula. Done. Chal. Done? Yes. So if you want, we can prove that also. See here. So if you need, I'll prove that. So this is a liquid column. So where the liquid is accelerating now. So let's suppose it is accelerating towards right. So now I am saying here the pressure P2, here the pressure P1. So now what are the forces that are acting? I can say that here the force will be equals to, so shall I write P2A, the force here is equals to, so the force P1A plus MA, yes or no? So P2A is equals to P1A plus P2A is equals to P1A plus MA. So whatever the force that is exerting here and the force that is exerting here, so this plus MA here. Yes. So now, so let's write P2A is equals to P1A plus, so in place of mass, so let me write the liquid has some density rho. So the rho is equals to mass by volume. So the mass is equals to rho into volume. So let me write rho into, in place of volume, let's write the cross sectional area of this one is A into length L. See, at this cross section, the force, what is the force that acts? So the P2 into A. So at this cross section, the pressure P2, P1A, and then this side one more pressure that is acting, one more force that is acting, MA, pseudo force. So that's why I wrote the pseudo force. So now I am writing pseudo force in terms of mass here. In pseudo force mass, I am writing in terms of density, area, length. So rho AL into A. So from here, so let me write the P2, let's cancel A either side, A. So P2 minus P1 is equals to rho AL, right? So the same thing we got. Done? Clear? So if the fluid is accelerating horizontally, so simply remember, so P2 minus P1 is equals to rho AL. A is the acceleration of the fluid and L is the length of the liquid column, and then rho is the density of the liquid given. Clear? This is the extra pressure, gauge pressure. So done. Chal. So let's move further. So we have got one question. So try to do this question on your own, guys. We have a question here. So try to do this question on your own. The liquid inside the container has density rho. Choose the correct option. So the liquid inside the density, inside the container has a density rho. So and its acceleration A is equals to G. So it is accelerating towards right. See. So first option PA minus PC. PA minus PC is equals to 2 rho GL. Obviously the pressure will be more at C, and the pressure at C is greater than pressure at A. Yes or no? So the first option is going to be wrong. Why? C is more, A is less. So they said PA minus PC. So this is not possible. So come to the second option, PC minus PB. PC minus, at C the pressure will be more. Yes or no? This side the pressure will be more, this side the pressure will be less. So at C pressure is more, at B the pressure is less. But so here it is given root 2 GL. So always we take the vertical height, guys, not the this is, they gave the diagonal length root 2. So don't take the diagonal length, we always take the vertical height. So this option is also wrong. PC minus PD. So at C pressure will be more, at D pressure will be less. Fine. So PC minus PD is equals to rho GL. Yes, this is correct, because so at the, for the accelerating fluid, the pressure at this point will be more, so and pressure at this point will be less, which is equals to rho AL. So here rho, the acceleration is G, length is L between C and D points. So option C is the correct one. And A minus D. So diagonally we do not take, so ignore this. Clear? Sure. So now let's try the second question. A closed rectangular tank is completely filled with water, fine, and is accelerated horizontally with an acceleration towards right. Acceleration is towards right. So pressure is maximum at and minimum at. So pressure will be maximum and minimum at. See here. First, so this side the pressure will be more. That's for sure. This side the pressure will be more, and this side the pressure will be less. And so we have A point and B point. So pressure at A and pressure at B is more. So in A and B again, where the pressure will be more? So as you go down, the pressure increases. Yes or no? So that's why at B it is going to be maximum. At B it is going to be maximum. Right? And then here the pressure is going to be less at C and D. So again in these two, where the pressure will be minimum? So D is the topmost point. C is the pressure will be there due to the vertical height. It is at some height H. Right? So at D the pressure will be minimum, and at C the pressure will be less but not less than the D. Yes or no? So at D it's going to be minimum, and at B it is maximum. So maximum at B, so minimum at D. Option 1 is the correct one. Clear? Chal. So now the shape of the liquid surface during the horizontal acceleration. So always remember, the liquid tends to align itself, so perpendicular to the net force. Okay, so the liquid surface tends to be perpendicular to the net force. So write that point. The liquid surface tends to be perpendicular to the net force. See here. Now, so this is a container we have. So in this, so the liquid is there. So this liquid is now accelerating. Let's suppose it is accelerating towards right. So if the liquid is accelerating, what are the forces that are going to act? So due to the weight of this liquid column, I am going to take, so this is a liquid column. So here, due to the weight of this liquid column, so the force, the weight, that is mg, which acts downward, and then so there will be some pseudo force which acts ma this side. Yes or no? So now the net force will be, so this is the net force, the F net will be this side. So I can say to the net force the liquid tends to be perpendicular. So the liquid, as a liquid accelerate, it tends to be perpendicular now. So that means so like this. So it will be perpendicular to the surface. See here, the net force is this side and the liquid surface is this way. So which is perpendicular. Clear? Understood? So that means, so the liquid raises to some height h. So from its original point, so it raises by some height h. So this is a height h. Done, everyone? Clear this point? So and then it makes an angle theta here. We can say this angle, or else, so this angle we can write theta here. So note this point quickly. First, done. Chal. Now, so if I take so a liquid column here, so consider the liquid column here I am taking, and then So this is the to the height it is raised. So I can write, so what is this length? Let the length of this liquid column be L. Length of the liquid column be L. So now you know that the pressure at this point will be greater than the pressure at this point. So the P2 minus P1 is equals to, so rho A L. So let it be equation number 1. Let it be equation number 1. So now again what I am doing is, so here the atmospheric pressure is P naught, and here also the atmospheric pressure is P naught. Yes or no? So now, so let the pressure here, let it be P2. So here let the pressure P1. Here pressure P2, here pressure P1. So now the P2 will be equals to, so the P2 will be equals to P naught plus rho GH due to this height vertically. So P naught plus rho GH. The pressure varies vertically inside the fluid, right? So here to here, P naught is the pressure here, P2 is the pressure here. That P2 will be equals to P naught plus, so let the density of this liquid be rho GH. So now I can write here, so P2 minus P naught is equals to rho GH, right? So let it be the equation number 2. So here in the equation number 1, so what I can do is here, see here. So the P1 is a pressure here, which is nothing but the atmospheric pressure. In place of P1, I can write the atmospheric pressure only. Consider this as the equation number 1. The P1 pressure is nothing but the atmospheric pressure, right? P1 and P naught, they both are same here. So in place of P1, I wrote P naught. Now, so consider the equations 1 and 2. So let me write it in the next slide. So we have got, so the P2 minus P naught is equals to, so rho GH, and the P2 minus P naught is equals to rho AL. So let it be equation number 1, let it be equation number 2. So now from 1 and 2, so we can equate the RHS part. So rho GH is equals to rho AL, rho GH is equals to rho AL. So here rho gets cancelled. So GH is equals to AL from here. So the H is equals to AL by G. So to what height the liquid rises, that is, so rho is equals to, the H is equals to AL by G. Okay, clear guys? And you can also write this thing. So what's that? So tan theta is equals to what angle of inclination, so the liquid rises. So the tan theta is equals to, so I can write H by L. So H by opposite by adjacent, H by L. So from here, shall I write here H by L is it nothing but A by G. See here from this one, so if you bring L to this side, so H by L is equals to A by G. So the tan theta is equals to A by G or H by L. So this is a concept. Clear? So what is the shape of the liquid surface during the horizontal acceleration? Very, very important. So first, the liquid surface tends to be perpendicular to the net force. Okay. So if the liquid is accelerating horizontally towards right like this, so the total liquid will be tilted to the left to the height some H. So what is that height, sir? So it is AL by G. And what angle of inclination it makes? So tan theta is equals to H by L is equals to A by G. Okay. So H is equals to AL by G. Clear? Chalo, done. So next. So we have got the question. So let's try this question on your own. See, try this question. A liquid stands at the plane level in a U-tube when at rest. So if areas of cross section of the both limbs are equal, so areas of cross section of both limbs are equal. Okay. So what will be the difference in heights of liquid in two limbs of U-tube? So when the system is given an acceleration A towards the right. So it is given acceleration towards right. So there are two liquids here. A liquid only one liquid. both the link. Okay, if okay, so one liquid. So they are asking, so if it is accelerated, obviously, so this will be raised to some height h. Yes or no? So this will be raised to some h. So what is that height h? So that height h is equals to, so I can write a, it is accelerating with a, so L, the length L by, so G, that's it. So a L by G, direct formula based question this one, a L by G. Clear? So the pressure here will be more, so the pressure here will be less. So obviously it will be this side, in this limb it will be increased, and in this limb it will be decreased. So to what height? So to a height of a L by G. Done, guys? Any doubts in this question? So let's move further. So if you want, you can apply the formula. Where do you apply the formula? So take the pressure here is equals to P2. So here the pressure is equals to P1. So the P2 minus P1 is equals to, so rho A L. The P2 minus P1 is equals to rho A L, right? So and then, so here the let the pressure P2. So here the pressure, the P1. Yes or no? So then P2 minus P1 is also equals to rho GH. So we'll write rho AL is equals to rho GH. So then rho gets cancelled. So acceleration, not acceleration, h we required, which is AL by G. So the same thing we get. Done now. So direct question, you can directly put the option. Chala, so let's move further. So try this question. Let's try this question on your own. Read the question first. Done. See, so in the question what they said, a U-tube of base length L is filled with same volume of two liquids. So same volume of two liquids of densities rho and 2 rho. So this liquid has density 2 rho and this liquid has density rho. So with an acceleration a towards, is moving with an acceleration a towards a horizontal plane. So if the difference in, if the height difference between the two surfaces becomes 0, so the height difference becomes 0, they are saying. So then height h is given by, so what is the height h is given by? Okay, so try to understand this concept. We consider 2 points here. So as it is accelerating towards right, so the P2 pressure here, let the P1 pressure here. Obviously the P2 will be greater and P1 will be less. So but don't use P2 minus P1 is equals to rho AL. So this formula you have to use only when the liquid is uniform. So same liquid is filled in the U-tube, but here the liquid density is different. So what is that? So 2 rho. Here the liquid density is rho. So then what we should do, sir? So here this length, it's a equal volume they said. So same volume. So obviously this length will be L by 2. So this length will be L by 2 this side, because here height is same, here height is same. Obviously this length and this length should be same, and it's having same cross sectional area they said. So that's why this length and this length should be same. Yes or no? So what I do is, so the P2 minus P1 is equals to, so the first liquid, let it be the first liquid, rho, 2 rho into its acceleration a into length L by 2. Yes. So plus, so the other liquid rho into, so what's acceleration a into L by 2. Yes or no? So this is P2 minus P1, and then here the atma, let the pressure P0 and let the pressure P0. So now write the another equation. So you know how to write the another equation, right? So P2 minus P1 or P2 minus P0. Yes or no? Done? So or else you can calculate this. P2 minus P1 is equals to, so 2 cancel, so rho AL by 2, so rho AL, which is 3 by 2 rho AL. So done. Fine. Let it be the equation number 1. So the another equation what we can write? See, simply, so the P2 is equals to, so I can write P naught plus, so here the density is 2 rho G H, height H S. So and then here P1 is equals to, I can write, so P naught plus rho G H height H S. Fine. So now shall we write what is P2 minus P1 here? So from these two, let it be equation number 1, and from these two I'll get P2 minus P1 is equals to, so 2 rho GH minus rho GH, which is rho GH, I get. So here P2 minus P1 and here also P2 minus P1. So now let's equate these two. So we get 3 by 2 rho AL is equals to rho GH. So sorry, rho gets cancelled. We need H. So which is 3AL by 2G, which is 3AL by 2G. So the height H they are asking. So 3AL by 2G. Option 2 is the correct one. Done. Clear guys, everyone? Chal. So try this question on your own. Same question. I guess same question. So the question 4. I guess same question is given twice. So ignore this one. So now let's go for the next concept, that is barometer. So the barometer used to measure the atmospheric pressure, right? So Torricelli is a scientist name, devised a method for measuring the atmospheric pressure. So the barometer is used to measure atmospheric pressure. It is used to measure the atmospheric pressure. So here, see here. So what's the concept is? So we take the tube, in that we fill the mercury, and then we place it in the tub where the mercury is there. So then we pour it down. So we close it one side after filling the mercury, and then we place it upside down. So then we remove the finger slowly, thumb slowly. So that what happens? So some of the mercury will come down, and here the vacuum creates. Here, so the vacuum will be created. So where the pressure is going to be 0. So the pressure is going to be 0. Actually, the vapors of mercury will be there, but the vapors of mercury will have the pressure 0 there. Okay. So in some textbooks they take like, so take the empty tube and place it in the tube, so that place it in the tub, so that the mercury will go up, so to a level somewhat. So then what happens? So they place the scale here and they measure the pressure. So whatever the pressure that they get, that's a atmospheric pressure. Getting clear guys? Understood? So a long glass tube closed at one end and filled with mercury is inverted into a trough of mercury. So this is a trough of mercury. So we place the long tube and we fill it with mercury and we close it one side and we close it with the thumb, and then we place it inside the trough. So some mercury will come down, and then after some time, so there creates a vacuum. So to whatever the mercury is there, to whatever the point, so that we measure. Clear? Understood? So here the pressure is going to be 0. Done. So now let's consider. So there is a point B and I am considering point C. So the pressure at B will be equals to the pressure at C. Yes or no? These are at same horizontal level. The pressure at B is equals to the pressure at C. How do you find the pressure at B? How do you find the pressure at B? The pressure at B is equals to, so the pressure here plus, let the pressure here it be P. So the pressure here plus, so rho GH. So this PB is equals to, the pressure at the top of the long tube is 0. This pressure vacuum 0 plus rho GH. So this PB, pressure PB is equals to rho GH we got. So this pressure we got PB is equals to rho GH. So and whatever the pressure that we get, so it will be the same here. So the PB is equals to PC. So this was found to be 1 atmosphere at a height of 76 centimeters for the mercury. Okay, so this device is known as a mercury barometer. So I'll write it here, see here. So in this experiment, it is found that mercury column in the barometer has a height of 76 centimeter at sea level. So at sea level means at 1 atmosphere, to get the 1 atmospheric pressure. So this mercury has raised to a height of 76 centimeters. Okay, clear guys? Chal. So then see, so rho is equals to, we have got, sorry, so the pressure is equals to rho GH, right? So how they calculate actually? We know the density of the mercury. So 13.6 into 10 to the power 3, and then we know the G value, and we know the height, which is 76 into 10 to the power minus 2 centimeters. 76 into 10 to the power minus 2. So this, when we calculate, so has come out to be 1 atmospheric pressure, 1 atm. Okay, sir, why only mercury we take? So why only mercury? So why can't we do this operation, the experiment with the water? So because the mercury is opaque, so high density, and then so it do not form vapors. So the, even if it forms vapor, so the pressure of the vapors will become 0. So it has high density and it is opaque and it do not form vapors. So don't form, or else no vapor, no vaporization. Clear? So due to these reasons, so we can take the mercury. So if we take the water, so the same atmospheric pressure, we get it at a height of, so almost 10 meters. Okay, so water is transparent. Understanding? Clear guys? So that's why we do not use water or any other liquid. So they used, so the mercury. Fine. Chalo. So this is simply the theory part. So no need to worry much about this. So next we have manometer. So in the manometer, so it is used to measure the pressure again. So here we fill the gas and here the liquid. So here the atmospheric pressure P0, and here the gas exerts some pressure. See here, whenever the atmospheric pressure is there, the liquid will come and compress this one, and there pressure creates, and again it will push, so that it creates a pressure here. So it creates a pressure here. So the pressure P, and the pressure at this point, let it be A, and the pressure at this point B. So they both will be equal. So the pressure at A is equals to the pressure at B. At the same horizontal level, the pressure will be equals to same. So the pressure at A, I consider it as P, is equals to, what is the pressure at B? Which is P0 plus rho, let the density of this liquid be rho. So rho GH. So pressure at this one, this pressure P is equals to P0 plus rho GH. Clear guys? Understood? Done. Chal. Done. So this is a gas pressure. So this one is a pressure of gas, or the total pressure we can call. So what is this one? So this is a atmospheric pressure. So just note this down first. Done. So why we use it, sir? Manometer, to measure the pressure of a gas. See here, what we are doing, we are finding the pressure of a gas, to measure the pressure of a gas. Chalo, done. This is about the manometer. So simple concept. So then we have important concept, that is the Pascal's law. So what Pascal's law says? So if you apply a pressure over some cross-sectional area, here. So at this cross sectional area you applied the pressure. So let the change in pressure here, it will be delta P. So the same pressure will be distributed uniformly throughout this container. The same pressure will be distributed uniformly throughout this container. And this Pascal's law is only applicable for the closed containers. So it is for the closed contained in a vessel. Here, whenever an external pressure is applied on any part of a fluid contained in a vessel, so for only enclosed fluids, this is for the enclosed fluids. Okay, so contained in a vessel, it is transmitted undiminished and equally in all directions. So the same pressure will be there in all the directions. So here delta P, and here delta P, here delta P, so here delta P, so here everywhere the delta P, delta P, delta P. Clear? Sure. So and then here also you can see the one more example. So if you apply the pressure here, so they all will raise to the same height. Here the same height h, here the same height h, and here the same height h. Height h, 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 like that. Done? Clear everyone? Sure. So let's move further. So one of the application of this Pascal's law is the hydraulic lift. So where the force will be the external pressure will be applied here. So what's the pressure here? So the pressure at this place P1 is equals to F1 by A. So the same pressure will be reflected here. So whatever the pressure that you apply here, so the same pressure will be applied reflect here. So the pressure P2 so will be equals to F2 by A2. Yes or no? So the F1 by A1 here, the cross sectional area A1 is equals to F2 by A2. So the pressure, whatever the external pressure you applied here, the same pressure will come. So as a result, so when you push it downward, so it will move up, but not as a same length. Let's suppose if you push it by some 10 centimeters, it may raise only 1 centimeter. Clear? The conservation of energy will applicable. Done? Yes. So we can say that according to Pascal's law, so according to Pascal's law, so we can write, so the pressure at 1 is equals to the pressure P1 is equals to P2. So which is F1 by A1. So force upon area is equals to, here also the force upon area, F1 by A1 is equals to F2 by A2. So or we can also write F1 A2 is equals to F2 A1. F1 A2 is equals to F2 A1. Clear? So the pressure P2 is equals to here F2 by A2. Done? Clear everyone? Chalo. So just note this down. We'll solve the questions. So this part is done. Chalo. So let's go for the questions. So do we have options for this? No. So let's try this question on your own. There are two pistons of a hydraulic machine have diameters 20 centimeters and 2 centimeters. So here the diameter is 20 centimeters. Here the diameter is 2 centimeters. Find the force exerted on the larger piston when 50 kg weight is placed. So here the 50 kg weight is placed. 50 kg weight is placed. Right. So on the smaller, 50 kg weight is placed on the smaller piston. Here the force applied is a 50 kg, which is nothing but 50 G is the force that is applied. So on the smaller piston, when the smaller piston moves through a 50 centimeters, how much distance it has moved down? So 50 centimeters. So by what distance the other piston moves out? So if it moves 50 centimeters, let's suppose it will move up by some distance x. Yes or no? So the distance moved here in this case, so whatever the distance that it moves, so not the same distance it will move here. No, because the conservation of energy is applicable. So you can observe it in this question. So see here. So what we can do actually, the first thing is the force upon area A1 is equals to the force 2 upon area 2. Yes, chal. So then what is the force 1? What is the force 1? Force 1 F1. is the weight that is acting. What is the weight that is acting? 50 G, right? And what is the cross sectional area? How do you find the cross sectional area here? So they have a piston, have hydraulic machine, have diameters. So that means here you can take the circular part. So you can take the circular part and write the if the diameter is 2 centimeters, the radius here it is going to be 1 centimeter, right? So let's write pi into 1 whole square, right? So which is equals to the force F2 by the area A2. So what is the area A2? So I can write its diameter is 20, so area will be radius will be 10 centimeters. So from there, first find how much force is applied here. So find that first. Simple concept. So first find the force F2. So then you can write A1 H1 is equals to A2 H2. You can apply the concept here. So let's suppose it has come down by some height H1. So it has raised by some height H2. Okay. So then A1 H1 is equals to A2 H2. So this must be constant. So the volume conservation too should take place. A1 H1 is equals to A2 H2. So here also you can do the same thing. A1 H1 is equals to A2 H2. Done. So can you guys try this question on your own now? Simple concept, right? Just try it on your own. I'll just stand aside. First to find the force F2. First find the force F2. Done. Sure. So first F2, how much you are getting? So this is 500 by pi gets cancelled. So this is 500. You can simply write. No need to write by. So pi gets cancelled. 500 is equals to. So F2. What is the force F2 we have got? We have to find actually. Sorry. So this is 100. So then we have F2 is equals to 5 into 10 to the power 4. So 5 into 10 to the power 4 newtons. So this much force is applied here. So then what is the area? A1 H1 is equals to A2 H2. This must be constant. So what is A1 area? How much area it is? So pi R1 square. So pi R1 square, which is nothing but simply substitute. You substitute the values. So here pi into R1 square into H1, 50 centimeters, 50 into 10 to the power minus 2. So which is equals to A2. So we have to find. So A2 we know already. So what is A2? So pi into the R2 square into, so what is H2? So let's find that. So pi gets cancelled. So I can write R1. What is R1? 1 centimeter, which is nothing but 1 into 10 to the power minus 2 whole square, right? So into 50 into 10 to the power minus 2 here, which is equals to, so here 10 into 10 to the power minus 2 whole square into H2. So let's calculate H2 now. So we have got 10 to the power minus 4 here into 50 into 10 to the power minus 2 here. So here 100 into 10 to the power minus 4 into H2. So here 10 to the power minus 4, 10 to the power minus 4 cancel, 51s are 52s are. So then H is equals to, I have got, so 0. H is equals to, H2 is equals to, so send this 1 by 2 into 10 to the power minus 2. So which is nothing but 0.5 into 10 to the power minus 2, which is nothing but 0.5 centimeters I have got. So 0.5 centimeters. So that means if you move it by 50 centimeters towards down, so then it raises by 0.5 centimeters only. So the conservation of energy. Clear guys? Understood the concept here? So in hydraulic lift questions, you have to do two things. So one is the pressure is distributed uniformly. So here the pressure F1 by A1, here the pressure F2 by A2 should be equal, and so the conservation of volume also you can apply A1. So let's suppose it has gone down by H1 height, so then it raised by some H2 height, so then A1 H1 is equals to A2 H2. So this is a concept. Clear guys? Chal. So that's it. So this question already we did, right? We don't need another slide. Chalo. So that's it from my end for today's session. So we'll meet in the next class, guys. So till then, keep studying. All the very best. Bye.